Okay, so I just wanted to create a video for you guys that really is almost identical, but kind of in conjunction with the selected slides. This way, a few of you may learn better by seeing me actually write this out than going through the slides. So I wanted to give you both options to watch to help you with the homework that is due this coming Saturday. It is math. It's not scary hard math. It's just learning how to use the equations correctly. It's nothing you guys haven't done before, certainly in your schooling. So what we're calculating today is solar declination and then zenith angle and solar altitude angle. So solar declination, you should have picked up now through your reading, is the latitude at which the sun is directly overhead at noon, meaning at that location at noon on a particular day, you would go outside, look straight up, and see the sun. Now, solar declination can only range between 23.5 degrees north and 23.5 degrees south, meaning for most of us taking this course, I think probably all of us, we are not currently in a location where we would be able to go outside anytime during the year, look up, and see the sun. And so a lot of times what we just want to find out is on a given day during the year, where is that place? In case you are curious or want to go. And so there's a couple of things that we need to figure out so that we can put them into the equation. So here at the top, you'll see I have the solar declination equation. It's 23.5 degrees times the sine of n. Okay, n is going to be the number of days to the closest equinox. So the first thing we need to know are what are our equinoxes. And again, through your reading, you should know the 2 equinoxes and the 2 solstices. Equinoxes, September 21st and March 21st. Solstices, December 21st and June 21st. You will see that date range go between the 20th and the 22nd of all those months. It does actually shift and change. But I typically use the 21st. That's right where we are right now in time. So excuse me, that's what we use. On the 2 equinoxes, our solar declination is 0, meaning the sun is directly overhead of the equator. And so that's why we use that value. Rather than using the solstices, we're going to use those equinoxes. The next thing we need to know is how many days are in each month. And there's a couple of different ways, besides looking it up, that you can remember this. There's the 30 days have 30 days have September, April, June, and November. All the rest have 31 except for February. And then there's also this little trick that someone taught me once. Let me put my, too close. There we go. Hands under here. That if you're up on a knuckle, it's a 31-day month. If you're down in a dip, it's not. And so you go January, February, March, April, May, June, July, August, September, October, November, December. What I'm going to show you here is really how I like to set these problems up. I think it makes things very straightforward. Now, it is very important, and I'm going to put this in the email and on the news post that will actually go along with this particular video, that you need to show me your work. I understand you're in an online class and you can go on Google and you can type in solar declination for any day. And you're going to be able to easily find this. It's going to calculate it for you. However, in order to get credit on the assignment, you need to show me that you have gone through the work to do this. If you do not show me work, you're not going to get full credit. So it's important that you show that work on that homework if you want the full credit. So I have my months lined up here. I'm just going to fill in the days. We'll use 28 for February because that's most common. So there we are, there. Okay, now, one thing that we need to know is depending, where the sun is will determine whether n is positive or negative. We're also going to see the same idea carry over then when we get our solar declination and then use it to find zenith angle. So if the sun is over the southern hemisphere, n is going to be negative. If it's over the northern hemisphere, n will be positive. So n is positive on any day that falls between March 21st and March 21st, and will be negative any day that falls between September 21st and March 21st. And so I typically, my little diagram, just to give me an extra visual, say, okay, n is positive here, n is going to be negative here, and n will be negative here. And again, all of this is just to kind of give me a little reminder. So what we're going to do now is we're going to walk through 2 separate days to find their solar declinations. And the first one we're going to start with is May 3rd. Okay. one of the first decisions you need to make is which equinox are you going to? Let's go to March 21st. May is pretty split down the middle, so either one would be fine. And anytime you do it, it's going to be fine. But it's easier typically to go to the closest. So we're going to use March 21st. Okay. So what I like to do here is think of myself being on a giant calendar and walking through those squares. If you think of those big desktop calendars that they have where they have the squares written down. So we're going to start on March 21st. And so to walk from March 21st to March 31st, which is the end of the month, we would go 10 steps. Okay. To go through all of April, to get to May, we would go 30 steps because there's 30 days in April. And then lastly, to get to May 3rd, we would go 3 steps. Okay. And so what we're looking at here is the 10 steps to get us to the end of March from the 21st, 30 steps to get us through all of April, and then 3 steps to get us to May 3rd. So we're looking at 43 as our end value. Okay. The next thing we have to figure out, is it positive or negative? Well, May 3rd falls between March and September, so we know n is going to be positive. Now all we have to do is put it into our equation. So we have SD, or solar declination, is 23.5 times the sine of positive 43. Okay, now some key things when you are using your phone or your calculator to calculate these, you need to be working in degrees, okay? And then remember our old friends, the math rules. If it's in parentheses, you need to enter it in parentheses. Parentheses go first. All of those fun things. So our solar declination here is going to be right around 15 or 16 degrees. We'll just say 16 for our purposes. Really, if you can go out to the 100th place, that's perfect. But otherwise, that's fine too. And so again, because our n was positive, when we put this into our calculator, this is going to be positive. Now, one thing that we'll talk about and also applies here is that any value that's positive is the northern hemisphere. Okay, so if our solar declination is positive, we're in the northern hemisphere. If our solar declination is negative, we're in the southern hemisphere. So for this particular one, we know that we are looking at a solar declination of 16 degrees north. Now, in your answer, it either needs to say 16 degrees north in this case, or positive 16 degrees, to show me that you know that we're in the northern hemisphere. So what that means for us is on May 3rd, if we want to go outside at noon and look straight up and basically be blinded by the sun, we would need it to be right around 16 degrees north. Okay, let's do one more example. Let's do December 6th. Our closest equinox this time is going to be September 21st. So just like we did the last time, this time September is 9 days because there's only 30 days in September. So the 21st to the 30th is 9. We need to go all the way through October at 31. We need to go all the way through November, which is 30. And then we need to go to the 6th in December. Okay, that's going to give us 76 days. So we stepped, if we're thinking about being on that big calendar, 6 steps. Okay, now again, we need to go back. Is our n going to be positive or negative? Well, December 6th falls between September and March, so we know it's going to be negative. So now this time in our equation, we're going to have SD equals 23.5 times the sine of negative 76. When we do that math, we're going to be left with roughly 22.8 with a negative value. So again, that either means you need to show negative 22.8, or as we said before, up here, a solar declination where the answer is negative, we're in the southern hemisphere. So in this case, on December 6th, if we want to go and stare at the sun at noon, we need to go down to the southern hemisphere at roughly negative 22.8 degrees, and we would be able to do that. Okay? Some common mistakes people make, not going to the equinoxes, but going to the solstices instead. It's important that we go to the equinox because solar declination is at 0. And so it gives us that even playing field. And then the last thing is to make sure you're including the positive or the negative when you look at N. Those are 2 common mistakes that pop up when people do the worksheet. Okay, so that's part 2 of your homework. I'll come back to part 1 at the very end of the video. Part 3 of your video is looking at calculating for all those places or any time during the year, how high is the sun actually in the sky? And so if we look at our little poorly drawn image by me, I'm not an artist by any means, the angle between straight over our head to where the sun is called the zenith angle. And then the angle from the horizon to the sun is called the solar altitude angle. Now our zenith angle, we're always going to make positive, meaning that that's kind of our starting point. So when we think about it, we're going to say, okay, if I'm looking straight up, how far do I need to bring my head down or my focus down until I see the sun? In some cases, very far north or very far south, during the right time of year, the sun's actually going to stay below the horizon. So we're going to be bringing down past an angle of 90 degrees because we really are only working, right, in our first quadrant or in our positive quadrant. Okay, if that sun is below the horizon, what we're going to find out is that our solar altitude angle is negative, meaning it's below the horizon. All right, so some things we have to think about here are going to be, again, our locations, both our latitude, so that's what lat means here, latitude, and our solar declination, which we just spent time calculating here, positive or negative. Okay, if both are in the northern hemisphere, both go into the equation as a positive. If both are in the southern hemisphere, both will go into the equation as a negative number. If we have a combination, you need to appropriately put in the positive or negative. Now, again, zenith angle is always positive, and the reason why that's the case is because we have these absolute value symbols surrounding the equation. Okay, so make sure you're taking that into consideration. So the example we're going to calculate here, and again, this is part 3 of your homework, so make sure you're calculating both zenith and solar altitude, is we will do 44 degrees north, which some of you are going to recognize that's roughly where Milwaukee sits. And then our solar declination that we're going to do is negative 23.5 because we're using December 21st. Now, I like to call the solstices and the equinox the big 4. Okay, and so I just have those solar declinations memorized. December 21st is negative 23.5 because we're in the southern hemisphere, degrees south. Okay, June, it's in the northern hemisphere, 23.5 degrees north or positive. And then again, during our equinoxes, it's going to be 0. Okay, so what you'll see in your homework is you're given a location, latitude, and a date. In some cases, you may be able to use what you've memorized here. Other cases, you may have to go through and calculate that solar declination as we did in section 2. So in this case, we have both our solar declination and our latitude. So again, it's just plugging it into the equation. So here we have positive 44, okay, that's our latitude, minus our solar declination, which is negative 23.5 because it's over the southern hemisphere. Okay, the key here is, especially with Google and every other site out there, there are some different combinations where you'll see people calculate solar declination within this equation. It's easy just to use these, okay? I would stick with these, especially if you're not super comfortable with math. Just fill in the blanks, okay? It's always latitude minus solar declination. Now, through math rules, we know that this can turn into 44 plus 23.5, okay? Certainly feel free to do this straight into your calculator. It will know what to do, okay? And it won't cause you any issues. But what this means is that Z equals the absolute value of 67.5, okay? In this case, we don't need a north or south because again, we're working in this first quadrant, so Z equals 67.5. Now, that means that on the last week of class, week 16, if you go outside at noon on the 21st, and you could measure how far your gaze comes down, it should roughly be 67.5 degrees from looking straight over your head until you're staring at the sun. Okay? Now, let's figure out how high, if we were looking at the horizon, we would need to bring our eyes up. So in that case, now all we have is solar altitude angle equaling 90 minus our zenith angle that we just found, 67.5. Okay, and so what that means is that our solar altitude angle is going to be, is that 22.5? Is that correct? I'm trying to check my work. 22.5. Yep, perfect. Okay, so that means from the horizon to the sun, it'll be 22.5 degrees that we're looking at. Okay, so again, this is not certainly difficult math. This is not differential equations or anything of that nature. It's just making sure you're plugging the right numbers into these equations. Okay. So we've now gone over part 2 and part 3. Part 1, you notice that you have a sun drawing and then the earth, and you are to determine, is the sun pointed towards the equator, or sorry, towards the sun, away from the sun, or neither? Okay, given the dates you're given. If we go back to this, okay, sorry, yeah, this is my first sheet I used. If our date that we're given in part 1 falls between March 21st and September 21st, we know that the earth should be pointed towards the sun because the solar declination is positive. If our date falls between September 21st and March 21st, we would know the earth's axis would be pointed away from the sun because we'd have a solar declination in the southern hemisphere. If we have one of the equinoxes, we know that the solar declination is 0, and so it shouldn't be pointed away or to the sun. Okay, so again, this is just another way to look at this math outside of the slides where I kind of hand worked through it for you. Remember, show all your work to get full credit. And if you do still have questions as you're working through it, please email me and I'll do my best to explain it a third way in writing to you as well. All right.